Hello guys and gals, welcome back. Let's dive right into some probability recap. Again, this is supposed to be a block day, so it's a bit of a longer one. Let's go ahead and dive right in. All right, to start off with, for our block day, I planned one of these sort of review questions for you. So go ahead and pause the video for a second and give this a shot. Okay, I say I have the answers written there at the bottom, but maybe you did or didn't get those. Let's talk about how to get these. If you got them, maybe skip ahead. All right, to begin, the radius length here. So here we have a circle. We're given that the area, and we have the angle in radians. So to start off with, I'm going to remind myself, what is the area of a sector equation? Well, I often forget, so I just start off with the area of a circle equation. Area equals pi r squared. Well, now I don't have a full circle, I only have a portion of the circle. So I multiply this by the portion of the circle that's here. So it's theta over a whole circle is 2 pi. And yes, of course, this equation can be reduced, and I'll go ahead and reduce in a second. But this is the basis of that equation. Just briefly to simplify it, my pi's can cancel out right here. And so another way of writing this equation, we'll have r squared theta over 2. Okay, from here let's plug in what we know and solve for what we don't know. Here they've given us the area, we're asked to find the radius, so let's go ahead and do that. Our area is 27. 27 is equal to r squared times 1.5 over 2. Let's go ahead and get after this. So first I'm going to multiply by 2. Multiplying by 2, we have 54 equals 1.5 r squared. Let's divide by 1.5. I'm going to cheat real quick and use my calculator. And we conveniently get that 36 equals r squared. Can you see that okay? Thus, r equals 6. Now, what are our units? Centimeters. All right, so we have our radius. Let's look at sector length now. Sector length is another equation that you might forget, but maybe you've remembered the circumference of a circle. Let me just draw a line here to make those difference. Circumference of a circle is 2 pi r. Well, now let's look at length. So our arc length, I'm going to call this arc length. What's that same equation? 2 pi r. But now we don't have a full circle here. We have a portion of a circle. So to take that into account, theta divided by 2 pi, entire circle. And now this equation simplifies pretty nicely. The 2 pi and the 2 pi cancel out. And so you get the arc length equation is just r times theta. Again, let's plug in what we know, solve for what we don't. We're looking for the arc length. They've given us the angle. We have the radius. So let's plug in both of those. Our radius is 6. Our angle was 1.5. And therefore our arc length equals 9. But now that's not the answer. You might be asking yourself, why is that not the answer? For here, remember back over here, it's asking for the sector perimeter. For the perimeter, we have to take into account this side and this side, both of those being 6. So 6 plus 9. We have our perimeter, our P is, what is that, 21? 6 plus 6 plus 9, 21 centimeters. All right, let's dive into the second one. All right, given the sine is 1/3, where x is an acute angle, find the exact value of cosine x and cosine 2x. Okay, now there's two paths for this sort of question, and I'm on board with you guys doing either, really whatever works better for you. Just briefly, the path I think people like less, and then I'll show the other path. The first path is just remember this identity of sine squared x plus cosine squared x equals 1, the Pythagorean identity. So given something like this, you can plug in what you know, solve for what you don't know. Now sometimes the signs can get a little weird here and you're going to have to double check your signs at the end. Generally I found people like this other path more, so let me actually dive into this other path. Remember, for all things trig, SOHCAHTOA still applies. These are still right triangles. Sine from SOHCAHTOA, sine x, remember that's equal to opposite over hypotenuse. So let me set that up here. So here that tells us that sine of our angle is equal to, here it said 1/3, 1 over 3. Now let me draw that triangle to help us see what this is. So here we have some theta, told us that was an acute angle. Opposite is 1, hypotenuse is 3. So now we have 2 of the 3 sides for a right triangle. Well, we're going to want to find this adjacent, so let's go ahead and use Pythagorean theorem to do that real quick. Just briefly to show that, we have 1 squared plus some unknown x squared equals 3 squared. X squared equals 8, or x equals square root of 8. Now technically it is plus or minus 8, plus or minus the square root of 8. Let's look back to the question. Here they've told us that x is an acute angle. And so if this were on a unit circle, something like that, and that, our x values or our cosine values are always positive over here. So that tells me that I'm using the positive square root of 8. If I said an obtuse angle, remember your cosine values for obtuse angles are all negative. But let me complete my triangle here. Square root of 8. Okay, now what we're looking for is cosine. Remember, cosine is adjacent over hypotenuse. So if I'm looking at my triangle, I can say cosine theta is the adjacent square root of 8 over the hypotenuse 3. Okay, that's the first question. The first question is asking, what is cosine x? Cosine of our angle is the square root of 8 over 3. There's that one. Okay, now the purpose of this question was to practice those double angle identities. I hope you guys have those written down. They come up often, so now you can really just choose your favorite one, and we're going to go and use that. All right, to help you guys out, here are those double angle identities. Again, I hope you have those written down somewhere and you can review those often. But for our purposes, let's look at this. Okay, so I can choose any of these to use for cosine of 2x. I'm actually going to choose this one. When I can avoid using radicals, I generally like to do that. So this one, we're just plugging in 1/3, and I think that's going to be an easier time. So using this bottom identity here, we're going to, let me make sure you can see my page here. I'm going to do the work right here so you guys can see it. All right, so we'll have cosine 2x is equal to, again, I'm using this one, 1 minus 2 sine squared x. So 1 minus 2. Now sine here, we've already established that sine is 1/3, so minus 1/3 squared. Okay, so this equals 1 minus 1/3 squared is 1/9, so this is 2/9. 1 minus 2/9, you will get 7/9 as your final answer. Cosine 2x equals 7/9. Okay, let's put this away and move on with this all. Okay, so from here, then I was going to do everyone's favorite, the block bonus. How exciting. Again, this is all about just giving you guys practice with what these functions look like. So I would encourage you, go ahead and make a couple coordinate planes and then give this a shot. So the first functions, let me just go ahead. Those are the 3 functions, and let's sketch those here in a second. Let me slide this over again. Okay, so 2 sine x plus 1. Well, the plus 1 shifts everything up 1. That's our principal axis. And this 2 out front, that's our amplitude. That makes it go up 2, down 2, up 2, down 2. But again, we've been shifted up 1. So let me just give this a sketch real quick. So here we have our general coordinate plane. This plus 1 shifts everything up 1. Maybe this is where 1 is. 1. Our amplitude being 2 means we're going to go up to 3. That's supposed to be a 3. And down to -1. Let me put those in. And then last piece, remember that sine starts at its principal axis of the origin, so something like that. And then sine goes up and down and something like that, with the period being 2 pi. The second question, here we have some quadratic. This quadratic is just been shifted to the right by 3 units, and it does its y vertex is 0. So here I'm just going to go to the right a little bit and just something like that. And finally, cosine of 2x, we often forget what happens if this is inside. Remember the identity, period equals 2 pi over b. In this case, our b value is 2, and so here we have our period equals 2 pi over 2 or equals pi. So here I'm going to draw a cosine curve just with an abbreviated period. Now remember, cosine starts at its maximum. So here, let me draw some sort of cosine curve, and this value there is now pi. It goes up 1, it goes down 1. There's those 3 functions. Let's look at the next one. 3 more functions. We saw one like this, so I want to give us another round of practicing that. Let me get some clean paper here. All right, this very first one. So this plus 5, that's our asymptote. I'm just going to sketch that plus 5 in right off the bat. Plus, as y equals 5 there. And now here, it's really important. Remember, exponents happen before multiplication. This negative is considered a multiplication. So this is really an exponential curve just in the negative direction. So from here, I'm drawing an exponential curve. Now, it's often easy to know what at least one intercept is. Now, if I plug in 0 here, I'm just going to imagine what happens if I plug in 0. Plug in 0, so it goes to 1, becomes -1, plus 5. So it tells me the coordinate 0, 4 is right here. And now I'm just drawing a negative exponential curve. Something along those lines. Let's look at this next one. Oh, a rational function. We haven't seen these for a little bit. The big things to remember for these are if you divide by 0, you get a vertical asymptote. If you have 0 divided by 0, you get a whole. And if top is 0, you get an x-intercept. So let's sketch this and see what happens. All right, first I see I have a vertical asymptote at -2. I'm just going to sketch that in. Vertical asymptote at x equals -2. Here we have another vertical asymptote at x equals 3. All right, we know our asymptotes. Now this, if I plug in 0, I know this whole thing is going to equal 0. 0 divided by anything is 0. So I also know if I plug in 0, that whole function is going to equal 0. Okay, and now it's kind of tough. Now it'd be kind of helpful to have a sign diagram or something along those lines. One other thing I forgot to mention. Here, looking at the degree of the top and bottom, here I see this is the second degree. I also see the bottom is second degree. So then it's just the leading coefficients for our horizontal asymptote. So here we have 5. Here there's a 1. So it tells me my horizontal asymptote for this is 5 over 1 or 5. So let me go back over here and sketch in 5. Okay, now I'm just going to connect the dots. You can do a sign diagram or something to figure out, but that's going to go positive there. I'm going to actually cheat for time's sake and see what this looks like. It's going to go up and touch, back down, and then come down, something like that. All right, this very last one. Ooh, that one's tricky. I don't know if you remember this sort of equation, r squared equals x squared plus y squared. That's the equation of a circle, this being the radius here. So that graph, which again you probably haven't seen for a little bit, but it's good to remember, is just a circle that's centered here at the origin with a radius of 3. Okay, my recording app maxes me out at 15 minutes, so I'm going to hustle through the rest of these. X-intercepts, domain and range. Domain, what x values are possible, what things break it. This one, x can't equal -2 or +3. This one, x has to be less than -3, between -3 and 3. And this one you can put in anything and so forth. Okay, let's move on. I would like to go over these review sets. We can do that. If you have questions, just shoot me an email. Okay, and then to keep practicing these, we're going to look at these couple probability review questions, these 8 questions. Again, the practice test, I'm going to find another way to get those to you. I haven't gotten those to you yet. Expect those to be posted probably on the calendar very soon. Otherwise, please dive in and try those. I'll see you guys next time.